Welcome to Talkcast and to part 2 of my discussion of Chapter 7, a conversation about justification from The Fabric of Reality by David Deutsch. Now actually, this is the third-ish episode on this particular chapter. I've inserted a supplementary episode, which is a discussion about some material in Realism and the Aim of Science, which is a very long book by Karl Popper, written sometime after The Logic of Scientific Discovery, which was his first book. And in that book, in Realism and the Aim of Science, among other things, he talks about something called corroboration. Now, I bring that up and I found it relevant to the present episode and to the episode before that, which was kind of an introduction to the conversation that we're going to have today, the literal conversation about justification. Because you can see Popper there trying to escape from the prevailing view of epistemology. The prevailing view of epistemology at the time, of course, was, well, you observe stuff and you observe stuff repeatedly and you become more certain. You confirm your theory in some way by repeatedly observing things, and you think that that theory is more likely to be true, something like that. And Popper rejected this whole idea. Popper rejected the idea that theories became more likely to be true, or you could assume they were more likely to be true based upon your confirming instances, based upon you seeing what you expected to see. The whole all swans are white thing, and so you're observing white swans and you become more convinced, apparently, the more white swans you see, that in fact it's true that all swans are white. Of course, this particular process of predicting the colour of swans and prediction in general is not even the aim of science, which is what Popper's whole project was. He was trying to explain something completely new, something hitherto that no one had really understood about what the creation of knowledge was and what science was all about. So you can see him trying to escape the mire in which he finds himself, the philosophical mire of his contemporaries and of the people that went before in trying to explain stuff about explanation. And in trying to get away from what they're saying, he's still using their language, and you can see that he's, well, in my opinion, trying to fill a void in our language and our vocabulary which doesn't need to be filled. You can do away with it. You can do away with so many of these words by his own lights, by the way in which he explains epistemology and how it works, by the fact that what we're after are criticisms. We're using this critical method to try and refute bad ideas, leaving us with a best existing idea. It's either that or we've got nothing at all. We're not in the position of trying to weight different ideas or to justify a particular idea as more likely to be true than some other idea. We're just not in that position. It just doesn't come up. It's not a problem to be solved. Hence, the whole problem of induction is a chimera itself. It didn't need a solution as such. The solution is, it was never a problem in the first place, because induction isn't a thing. There is no hole at the centre of science where we need to try and become confident in our theories because the king of knowledge is something like mathematics or logic or something like that, and what we're trying to start with are absolutely certain foundations, and on that building an edifice of ever more certain claims about reality. That's just not what's going on. Popper's entire conception turns that on its head. What we're doing is we're conjecturing, we're guessing, we're creating explanations that can be tested against reality and can be shown to be wrong. And if we can't show them to be wrong, well, lucky for us, we've learned something about reality. We keep hold of that bit of stuff, that bit of information about reality, and we call it knowledge, something we know about reality. Okay, so this is what we explain here at Talkcast. This is what David Deutsch explains throughout the beginning of Infinity. And why it should be relevant for me to go all the way back to Karl Popper and the realism and the aim of science and talk about this corroboration stuff is because David uses the language of corroboration here in this chapter, and I think quite rightly, once again, speaking in the language of people who are going to disagree. And there are still people who disagree today. Bayesianism, we have to admit, is still a far more popular and an ascendant even epistemology. People still have this idea that what science is about is trying to predict the future, and you're trying to be more and more sure or confident or certain that this particular theory is actually a true account of reality or something like that. So if you've ever been in a conversation with someone who disagrees with Popperian epistemology, it can sometimes be difficult to get across what you're saying because just simple things like claiming to know something in the Popperian framework means you have an explanation. It could mean you have an intuition, but in any case, you have some idea that solves your problem. That's what it means to know something. You've got a solution of some kind. Sometimes you can know how to ride a bike without having an explicit explanation of what's going on. What you've got is inexplicit knowledge and a whole bunch of implicit assumptions about exactly how your body moves and that kind of thing. But you know how to ride a bike. It's a form of knowledge, even if you can't explain it in words, or you can't explain it fully in words. Popper's account of knowledge takes account of this kind of thing. Because among other things, it's knowledge that can be improved over time. You never need to justify as true this bit of knowledge that you have about how to ride a bike or how to swim or any of this other inexplicit stuff. It's stuff that, well, inexplicit knowledge just isn't stuff that forms a part of anything like Bayesian epistemology or induction. And whatever the case, when we're talking about explicit explanations, the rules don't need to change, not all that much. We don't move from having guesses about how to do stuff, like ride a bike, or guesses about what reality is like, into an area of certainty. That's not what's going on. So here, in this chapter before us, chapter 7, a conversation about justification, David is going to have an imaginary conversation with someone who doesn't think that they're an inductivist, so they're called the crypto-inductivists, but they have an induction-shaped hole in their way of thinking about the world. They don't understand why we should rely on our existing theories, our best existing theories of reality, our scientific theories. They think, the crypto-inductivist thinks, there needs to be some process by which we justify, by which they presumably mean justify as true, any given theory that we have at a particular time. And David is rejecting that whole idea, as Popper indeed rejected that whole idea. But our language, our common language between Popperians and non-Popperians and just person on the street thinking about stuff, well, we share this language we call English and we have a whole bunch of words, some of which can be quite misleading. Justification is one of them. What does justified really mean? Well, it could mean something like showing as true, given some assumptions you already know are true. Now, never mind how you know those assumptions are true, of course you don't. Putting that aside, as David said, and as I'll emphasise again now, in the introduction to the audiobook version of this, he said there that when he uses the word justified or justification here in the Fabric of Reality, what he intends is the normative claim. In other words, saying not that our best theories are justified as true, but rather you are justified in the sense of you should use your best theory. What else could you do? You want to explain some sort of cosmological phenomena like gravitational lensing? Well, the only thing you can do, it is right, you are justified in using the general theory of relativity. You're justified in using the evolution by natural selection in order to go through the process of explaining exactly how it is that certain species exist in reality right now on planet Earth. And presumably, any life that exists out there elsewhere in the universe, you're also justified in assuming that that life there has also evolved via a process of natural selection because we know of no other process. And all we can go on if we have problems like, let's say, one day we observe alien life and we want to explain where did that come from, our best theory is that all life, no matter where it is and of what form, has evolved via a process of evolution by natural selection. Now, could that be wrong? Of course it could be wrong. So we're not justified in thinking our theory is true, literally true, but we're justified in using it. Why? In order to solve our problem, the best that we can at any given time. And solutions to problems don't need to be the final, ultimate, optimal solution for all time and everywhere. They just need to solve your problem now. To your satisfaction, to the scientist's satisfaction, to the satisfaction of being able to say, problem solved, and move on to the next best problem, the next most interesting problem, the next thing that is important to you. Okay. So I'm not going to read the entire dialogue today here in chapter 7 because it's a long dialogue, and I think that listeners to Talkcast, if you've made your way through the beginning of Infinity, you'll have a solid grounding in an understanding of what epistemology is all about. So I just want to highlight sections of the conversation that can be illuminating to us and just to, of course, enjoy the clarity of David Deutsch's writing on this. I'm also going to pause at certain places where I think that, as I did in the last episode about this particular chapter proper, where I was saying that, well, we could probably rephrase this in a slightly different way in light of David's own more recent work on this, in light of what David says in the beginning of Infinity, and amongst other things, in his paper, his even more recent paper than the beginning of Infinity, that paper being the logic of experimental tests. And I think that now as far as I'm aware, is the pinnacle of our understanding of exactly what science is about and the role of things like observations, experiments in scientific discovery. That is right now our most refined understanding of things. And so we can draw a line, if you like, all the way from pre-Popperian stuff to what we might say is early Popper. And in Realism and the Aim of Science, Popper admits he's got an early version of himself. And the early version of himself in the logic of scientific discovery was saying things like, and he admits himself that this was an error, saying things like, theories can have a degree of confirmation. Now, he was wrong about that, and he admits he was wrong about that. And so he moves on to degree of corroboration, because he thinks that some theories are more probable than other theories. And we, of course, now think this is wrong, following the work of David Deutsch. So David Deutsch has done stuff in epistemology since the Fabric of Reality, which kind of does away with some of the ways of phrasing these things. And so there's a more refined way of understanding some of this stuff, certainly in the Beginning of Infinity, and certainly in something like The Logic of Experimental Tests, his academic paper on this. And if you're interested in that, it's kind of hard going. It's focused on, well, the full title of the paper is The Logic of Experimental Tests, particularly of Everettian quantum theory. And so it can get quite technical in places. Now, I've written a guide about this, and it's on my website, just called The Philosophy of Science, and there is a podcast all about devoted to this as well. And if you're interested in that, you can go all the way back to Talkcast episode 22, The Logic of Experimental Tests, where for a little over an hour, I go through my understanding of and my reading of the logic of experimental tests, certainly just excerpts thereof. And so that too can form a supplement to something like this episode, where we are looking at the debate between Popperians and Popperian epistemology and, well, the rest of people who think about how it is that science accomplishes what it does, or what the purpose of science is, and why we should rely upon our best explanation at any given moment in time. Why this is a debate, from our point of view, is a mystery. After all, what else can you do but rely upon your best existing theory? And if you can't show your best existing theory as actually, finally, once and for all true in some way, who cares? You've got nothing else to rely on. And I guess push come to shove, a reasonable Bayesian would say the same thing, but one wonders what they're really engaged in if they're trying to increase their confidence, increase their credence in a particular claim. Okay, without further ado. Now, I did think to myself, without further ado, I say, and then he goes on to make more of an ado. I did think to myself, should I get one of my friends or someone else to play the role of David or play the role of crypto-inductivist and thereby have a proper dialogue? And after much thought about this, I thought, no, I will just read both parts. So this may become a little bit irritating, and I'm not going to try and be a voice actor for this. I'm just going to read it dry and pause where I think there are interesting things to talk about. Okay, so let's go. This is the beginning of the actual dialogue, the actual conversation about justification that David has in the Fabric of Reality, Chapter 7. And he begins with himself asking the question of the crypto-inductivist. David says, quote, "Since I read what Popper has to say about induction, I have believed that he did, indeed, as he claimed, solve the problem of induction. But few philosophers agree. Why?" And the crypto-inductivist replies, "Because Popper never addressed the problem of induction as we understand it. What he did was present a critique of inductivism. Inductivism said that there is an inductive form of reasoning which can derive and justify the use of general theories about the future given evidence in the form of individual observations made in the past. It held that there was a principle of nature, the principle of induction, which said something like, observations made in the future are likely to resemble observations made under similar circumstances in the past. Attempts were made to formulate this in such a way that it would indeed allow one to derive or justify general theories from individual observations. They all failed. Popper's critique, though influential among scientists, especially in conjunction with his other work elucidating the methodology of science, was hardly original. The unsoundness of inductivism had been known almost since it was invented, and certainly since David Hume's critique of it in the early 18th century. The problem of induction is not how to justify or refute the principle of induction, but rather, taking for granted that it is invalid, how to justify any conclusion about the future from past evidence. And before you say that one doesn't need to, and David interjects, one doesn't need to, the crypto-inductivist then comes back with, but one does. That is what is so irritating about you Popperians. You deny the obvious. Obviously, the reason why you are not even now leaping over this railing is in part that you consider it justified to rely upon our best theory of gravity and unjustified to rely on certain other theories. Of course, by our best theory of gravity in this case, I mean more than just general relativity. I am also referring to a complex set of theories about such things as air resistance, human physiology, the elasticity of concrete, and the availability of mid-air rescue devices." End quote. So remember the context here. What's going on is the two characters, David and the crypto-inductivist, are standing at the top of the Eiffel Tower. And the whole point of the dialogue is that David is trying to explain why he is justified in relying upon the best existing theories as to why he shouldn't jump over the railing. And the crypto-inductivist is saying, well, no, you haven't properly justified that claim. There's no good reason, so to speak, for relying on this best theory. So there's some back and forth at this point between David and the crypto-inductivist, and I'll just leap to the point where the crypto-inductivist tries to summarise David's argument. And what the crypto-inductivist says is, quote, "So to summarise, you believe that the evidence currently available to you justifies the prediction that you would be killed if you leapt over the railing." End quote. Now, dear listener, if you hear something like that, let me just say it again. The crypto-inductivist is saying to David, you believe that the evidence currently available to you justifies the prediction that you would be killed if you leapt over the railing. Does anything spring to mind? It perhaps should. The evidence doesn't justify anything. What's the point of evidence? The point of evidence, the purpose of evidence, why one gathers evidence in science at all, is to decide between theories already guessed. It's not there, its function is not to justify as true or as more true a particular theory. Instead, it just rules out some whole bunch of theories and is only explained by the sole standing theory. So the crypto-inductivist is wrong to summarise David in that way. Also, the crypto-inductivist is absolutely focused on prediction. Now, in this particular case, I guess that being focused on prediction is what it's all about. After all, they're debating whether or not one is justified in leaping over the railing and thinking they are or are not going to be killed, given the best current explanation. But the justification for not leaping over the railing from the top of the Eiffel Tower is all about the fact that not that general relativity and those other theories that were mentioned earlier are absolutely true or anything like that. It's just that it's the only theory you've got. It's the only theory you've got. Everything else has already been ruled out by various other experiments. And so that theory allows you to derive certain predictions. There are certain consequences that follow. One of which is, well, anything that goes over that railing is going to hit the ground and be destroyed upon impact. That's just what happens. A prediction, I say, is something you logically derive from a given explanation, a given good scientific explanation. It's just a consequence. It's one of the things that follows from, assuming all else equal, which is often a hard thing to do. You can't always assume all else being equal, because in our real world, people's choices, human creativity comes into play rather often. So only in very well-controlled environments, like in a laboratory, can you do properly controlled experiments. And this is why prediction is valid there. We could say, if you like, the predictions made in the laboratory where you have carefully controlled your variables and all of the conditions and you understand the functioning of the equipment well, then you are justified on relying upon the predictions. But outside of the laboratory, things get more tricky. Things get more tricky, especially in the realm of human affairs, and that includes things like anything happening on the Earth, which could be geological or meteorological or climate-related, or to do with the extinction of animals or not. The evolution of life now on Earth is very much affected by the choices that people make. And so our capacity to predict the behaviour of systems here on Earth depends upon knowing what people will do to impact those systems. And We can't predict what people will do, especially people of the future. We don't know what knowledge they will have or will create. And so this is why prediction outside of the carefully controlled laboratory, and by the way, that includes the carefully controlled laboratory of deep space, which presumably there aren't people out there affecting things just yet, but places where you can ignore the choices and effects of people and knowledge creation, if you can do that, then you've got a set of valid predictions. Otherwise, what do we say? We say we've only got prophecies, wild guesses where we presume that we know the content of our future theories. And often when it comes to prophecy, people are assuming they know the content of those future theories to be exactly the same as the content of theories today. In other words, whatever problems we have today will still be there in 100 years because we won't have created the knowledge to fix the problem then? Well, something like that. When you hear about people talking about the distant future and some existential catastrophe that's on the way, talking about that today, they're engaged in pure prophecy. They don't know what the next generation is going to do. They don't know what they are going to do 20 years from now, which could have an effect on the very problem they are so agitated in being worried about right now. And I think it's good for people to be worried about certain problems today that could have an effect in decades to come. But making prophecies about this particular thing actually happening, well, that's wrong. So that's the distinction between prediction and prophecy. But here we're focused on prediction. So let me go back and recap what the crypto-inductivist has just said and go on with what David's response is. So the crypto-inductivist has just said, quote, "So to summarise, you believe that the evidence currently available to you justifies the prediction that you would be killed if you leapt over the railing." And David says, "No, it doesn't." And the crypto-inductivist says, "But damn it, you are contradicting yourself. Just now you said that prediction is justified." And David says, "It is justified. But it was not justified by the evidence. If by the evidence you mean all the experiments whose outcomes the theory correctly predicted in the past. As we all know, that evidence is consistent with an infinity of theories, including theories predicting every logically possible outcome of my jumping over the railing." The crypto-inductivist says, "So in view of that, I repeat, the whole problem is to find what does justify the prediction. That is the problem of induction." And David says, "Well, that is the problem Popper solved." End quote. And quite right. And what I'll say here, because I'm just going to skip over a whole bunch of things, is if you cast science in terms of being a project about trying to predict the future and almost nothing but, this process of generalization or extrapolation, that a set of observations in the past should continue off into the future because you can draw a straight line through a particular trend without an explanation. You're assuming an explanation. The explanation you're assuming is that observation in that set of observations in the past is somehow necessarily required by laws of physics or something like that. And so therefore there is a law of physics or something that ensures that what you've seen in the past will continue to be seen in the future, which isn't much of an explanation. It's just kind of assuming there's an explanation beneath all this. But you're not searching for explanations. You're searching for generalizations, extrapolations, the ability to make predictions. This is the whole reason induction is just so vacuous, pointless, a misguided attempt to understand what is going on with science. Science, like every other domain that is of interest to people in academic circles or just in problem solving in general, it's actually about creating explanations. It's about understanding the world. And once you have some understanding, then, if you're lucky, you might be able to make a prediction about something. Sometimes not. Sometimes even our best explanations don't allow us to make predictions. It's kind of in the physical sciences. And even then, not all the physical sciences, but in the physical sciences, we can make some predictions sometimes under some circumstances, as I already said. One of the trope examples I like to use is, well, we have this theory of acids and bases. There are these two kinds of chemicals that exist in the world. One creates hydronium ions when dissolved in water. These things are called acids. To a first approximation, you say it's the hydrogen ion, H+, that goes floating around in solution. It's not quite like that, by the way. It actually creates these things called hydronium, which is H3O+. Never mind that. Whatever substance dissolved in water that produces such ions we call an acid. And on the other hand, we have these things called bases, which, when dissolved in water, produce the hydroxide ion. The hydroxide ion is OH minus. It's a negative charge. And so things like sodium hydroxide or potassium hydroxide, these are bases. And they can be used when combined with fats to make soap, but never worry about that. Now, all of the soluble bases, we have this word called alkali, and so alkali is just a name for a base which will dissolve in water, because there are certain bases that don't dissolve in water. Now, bases or alkalis dissolved in water produce the hydroxide ion, OH minus, and to a first approximation, the acids when dissolved in water produce H plus, the hydrogen ion. Now, when you mix an acid and a base of equal concentration, equal amounts, and the correct molarity and all this sort of stuff, what you get, the products that you get from the reactants are acid plus base, is something called a salt plus water. Now, where did the water come from? Well, the water came from the hydrogen ion over here from the acid, H, plus the hydroxide ion from the base, OH minus over there. H plus OH gives you H2O, water. And so that's where the water comes from when you mix an acid and a base, or you combine an acid and a base. What am I telling you all that for? Well, that's a good explanation about what's going on chemically with stuff, and it allows you to make specific predictions. That's the general universal rule, that anywhere in the universe that you happen to have an acid dissolved in water and a base dissolved in water, then you will get a salt and water being produced as the products. And so you take a specific example, and my trope example I like to use is, because it's the one I can it's the one I can easily do in my head, is hydrochloric acid, which is HCl. That's the chemical formula for it. And then sodium hydroxide, NaOH. This is probably the easiest reaction of all. Equal concentrations and equal amounts of that will produce as products, you've got HCl plus NaOH, you will get sodium chloride, NaCl, that's plain old table salt, and H2O. That's a prediction. So if you give me any acid and you give me any base, which can dissolve in water, then I should be able to tell you what the salt is, what the specific salt is that is going to be produced, as well as being water. That's a prediction. I can make that kind of prediction. And in fact, any reasonably competent high school chemistry student would also be able to tell you precisely what the concentrations are required and the volumes are required. This is the process of titration, by the way. You can figure out the concentration of an unknown base given a certain concentration of a particular acid, and you combine these things together and you can do quite simple calculations. You pull out your periodic table and your pocket calculator and you can calculate this stuff. So you can make even more precise quantitative predictions about this kind of stuff. This is physical chemistry. And organic chemistry allows you to do the same thing. This is the wonderful thing about chemistry. It allows these precise, very precise predictions, exceeded perhaps only by physics itself. But then, sticking within the realm of physical stuff, we only have to move to geology, and suddenly the systems become too complex for us to make precise predictions. We understand some stuff, but we don't understand enough to make the predictions that we would like to, if only we could. For example, we can't predict earthquakes, and we can't predict volcanic eruptions. Not to the precision and accuracy that we would like to. We'd like to be able to have warnings well ahead of time that a particular earthquake is going to happen in a major city and do whatever it takes in order to protect people and structures and that kind of thing. But instead what happens is the earthquake happens, the buildings fall down, people get hurt, and then we come to have a better understanding after the fact of how earthquakes happen. But we don't have the capacity just yet, to make these predictions ahead of time. And that's a shame. And that's just geology. Rocks moving around. Well, tectonic plates, but you get my point. These are, by comparison, simple systems as compared to, well, anything involving human affairs. One day we'll be able to predict when earthquakes are going to happen. One day, presumably. It must just come down to physical forces, and it must just come down to how much stress is being placed upon these tectonic plates, which we don't have the ability to measure precisely just yet. But perhaps one day we will. We must be able to one day. And then we'll be justified in the future relying upon the prediction from that good explanation. We just don't have a good enough explanation just yet. We are right, we are justified in predicting, following a good explanation of how acids and bases interact, exactly what, for example, concentration of base we need to neutralize a particular acid. That's another prediction that we can make, and we're justified on relying on certain calculations. Okay, that's the normative thing to do. We should use chemistry in order to solve those kind of problems in titration, let's say. And if someone's talking about jumping over the railing of the Eiffel Tower, we are justified in predicting they're going to hit the ground at such a velocity that it'll kill them. Now, why? Because our best explanation, the combination of our best explanations, but chief among them, general relativity, says that you're going to accelerate towards the ground at a particular rate, slowed only a little by things like air resistance. But your skull's going to hit the ground and you're going to be dead. And that conclusion is justified in the sense that it follows from the assumption that all those other theories are good explanations about what's going to happen. They don't have to be true in any final sense, but they capture some truth about reality, some truth. And some of that truth is that you're going to accelerate towards the ground. So once again, we have more back and forth between David and the crypto-inductivist. And I'm going to pick it up where the crypto-inductivist says, quote, "Now listen carefully, because you have just said something which is not only provably untrue, but which you yourself conceded was untrue only moments ago. You say that the outcomes of experiments, quote, refuted all the rival theories, end quote. But you know very well that no set of outcomes of experiments can refute all possible rivals to a general theory. You said yourself that any set of past outcomes is, I quote, consistent with an infinity of theories, including theories predicting every logical possible outcome of my jumping over the railing, end quote. It follows inexorably that the prediction you favour was not justified by the experimental outcomes because there are infinitely many other rivals to your theory, also unrefuted as yet, which make the opposite prediction." And David responds, quote, "I'm glad I listened carefully, as you asked, for now I see that at least part of the difference between us has been caused by a misunderstanding over terminology. When Popper speaks of rival theories to a given theory, he does not mean the set of all logically possible rivals. He means only the actual rivals, those proposed in the course of a rational controversy. That includes theories proposed purely mentally by one person in the course of a controversy within one mind," end quote. And this is just me talking now. Yes, of course. Now, it would be impossible to enumerate all the logically possible theories. There wouldn't be a set, it would be some weird class of things. And if we take the worldview of the beginning of infinity seriously, then we must presume there are an infinite number of theories better than our best existing theory yet to be generated. That's part of the beginning of infinity, that we will get ever closer and closer to describing reality without getting ever a final description of reality. Because reality itself has this infinitely complex character. The universe is vast beyond our imagination. And every time we discover something new about it, it reveals a whole bunch of new phenomena that we are only just scratching the surface of. And we're always just scratching the surface. So there must be this, in theory, infinite number of theories yet to come. We're never going to get to the end of our process of scientific discovery. No matter what people say, no matter what books are written about the end of science, no matter what other podcasters say that we're almost there with a completed science of this, that, or the other. No, we are coming to understand objective reality ever better over time. But the end is nowhere near in sight. And isn't that fun? That's great. That's cool. That means there's always something new to do. And you can start anywhere and point yourself in any direction, and there'll be problems, and you'll be able to make progress. So it's not possible to rule out all of the theories, because there's a whole bunch of theories, an infinite number, as I just said, that are better than your existing theory. Okay, you're yet to think of them. No one has yet thought of them, but they will. They will think of them because they will need those to solve problems yet to be encountered. Problems that will only be encountered once certain problems have been solved now with our existing theories. So, the existing theories, there are certain problems with, for example, the meshing of quantum theory and general relativity. What is the ultimate nature of reality? Is it discrete or continuous? Is it some other hitherto unimaginable third thing? I don't know. But the fact is, we don't know the ultimate constituents of matter. And we may never know the ultimate constituents of matter because there might not be ultimate constituents of matter. We just keep finding smaller and smaller, different things that themselves are made up by other things. So I'm skipping ahead, and the crypto-inductivist objects to being called an inductivist at all because they don't believe in induction. As they say, as the crypto-inductivist says, quite offended, quote, "It really is perverse to call a person an inductivist if that person's whole thesis is that the invalidity of inductive reasoning presents us with an unsolved philosophical problem." And David says, "I don't think so. I think that that thesis is what defines, and always has defined, an inductivist. But I see that Popper has at least achieved one thing. Inductivist has become a term of abuse. Anyway, I was explaining why it's not so strange that the reliability of a theory should depend on what false theories people have proposed in the past. Even inductivists speak of a theory being reliable or not, given certain evidence. Well, Popperians might speak of a theory being the best available for use in practice, given a certain problem situation. And the most important features of a problem situation are what theories and explanations are in contention, what arguments have been advanced, and what theories have been refuted. Corroboration is not just the confirmation of the winning theory, it requires the experimental refutation of rival theories. Confirming instances in themselves have no significance." End quote. Yes, so this is one of the motivations for my immediate prior episode to this one, where it's titled Corroboration, because I think Popper was trying to escape from this kind of language. And I think I can see here, and of course I can't speak for David, but I can see here that David doesn't use this kind of language in The Beginning of Infinity or much at all since the Fabric of Reality, because I think it's kind of superfluous to our needs. As he says there, quote, "Corroboration is not just the confirmation of the winning theory." Now, what I would say, and I think even Popper kind of admitted, is that, well, confirmation's not a thing. What does confirmation mean? To confirm something means to show as true in some way, or it just means the observation is consistent with the theory. But we've already said here in this chapter already that, there are an infinite number of theories that could be consistent with any set of observations. Fine. So we don't need to worry about confirmation. And I think for similar reasons, we don't need to worry about corroboration either. All of these things are kind of on the positive side of the ledger, trying to support a theory in some way. But we don't need to support a theory at all if it's the only existing theory. And this is our situation in science and everywhere. We have a theory. It is exceedingly rare. Exceedingly rare. I'm just laughing at myself because I think I've said this phrase so often recently. It is exceedingly rare to have multiple theories of anything at all. At the moment, you look at something like dark energy, and people might very well say to me, well, this is a problem, but you look up the Wikipedia article and there's all sorts of theories about dark energy, and I would just say no. None of them count as theories in the sense that I'm talking about them. What a theory is in my usage of the word here, now, of course, theory can just mean any old wild guess that you like, but it should mean good explanation. And this is what we're really talking about when we're talking about having multiple competing theories that make a claim about reality. What we're saying is multiple competing good, hitherto good explanations of reality. Hard to vary accounts of the world postulating the existence of specific physical things. In the case of Newtonian gravity, the postulation of a physical force, an action at a distance that travels instantaneously between bodies. Okay, that's postulating a real physical thing that we can experimentally test for, and in fact, fails the test. And on the other hand, you've got general relativity postulating the existence of a true fabric of space-time that can bend and warp in the presence of mass and energy, and we can test for that too. And in fact, passes the test. Now, not to say that it's confirmed as true or anything like that, it's gone unrefuted. And if you want to explain stuff like gravitational lensing or the bending of light during an eclipse or what's going on with a black hole, you've only got one explanation. Now, forget support. We don't need to support it. Like, why? What's the point? What help is support in that situation? Let's say we had 100 points of support. Great. Well, what's the rival? There's no rival. It's not like there's something else over there with 90 points of support. There's nothing. The next best thing you've got is Newton's theory of gravity. It's already refuted. It can't do any of this other stuff. It can't explain precisely what's going on with gravitational lensing. It can't explain black holes in the same way. It can't explain gravitational waves, so on and so forth. Just so much stuff now. There's only one theory, and this is true across science. I mentioned earlier the theory of acids and bases. The modern understanding of that, whatever the chemists call it now, there is no rival theory. There used to be different rival theories about what an acid and a base was, and how they behave. But the history of science shows that there was this gradual process of incremental improvement where the previous theories of acids and bases were ruled out, leaving us with the modern understanding. The same as the history of the atom's another interesting one, where people just didn't know. They kind of had the idea there was an atom, but what was the structure of an atom? No one knew. Was it kind of like this plum pudding model where the protons and neutrons and electrons were all just mashed together? It took a while for us to escape from that view to moving towards something that looked kind of like a solar system, to today where you've got this set of fungible instances of an electron in orbit, with scare quotes around the word orbit, the nucleus, where the nucleus is made of protons which are really made of quarks, and the electrostatic force and the Heisenberg uncertainty principle is sort of in tension, and this is why you have atoms. So this is our modern understanding, and it has refuted all the previous theories of atomic theory. So is true with acids and bases, so is true of gravity, and so this is our situation. And by the way, not just in science. You can talk about theories of history. You can talk about theories of aesthetics. You can talk about theories of morality. Now, sure, in some of these areas, there are still debates raging. But generally speaking, broadly speaking, we have a theory, an explanation, and there are no rivals. When a problem arises, then creativity needs to start. Then you need to start thinking up new explanations. And if you're really lucky and you try really hard, then you'll find the explanation. The explanation. You won't, it's not like you create two. You'd be in a very fortunate position if you were able to create two rival solutions to the problem that you have. But that usually isn't what happens. You've got an existing theory. You make an observation which doesn't seem to fit with your existing theory. So you've got this problem. So then you create another theory. And so then you figure out, this theory explains why that observation doesn't fit with that theory. But my new theory, it does explain the observation. Then you're back to one again. You've gone from one to one. This is what happens. Okay, so yeah. Never mind corroborating, never mind confirming, never mind saying that one theory is more probable than any other. You've got the one. You've got the one. Okay, let me keep on going. The crypto-inductivist says, having just been told basically that by David, quote, crypto-inductivist here, saying, very interesting. I now understand the role of a theory's refuted rivals in the justification of its predictions. Under inductivism, observation was supposed to be primary. Skipping a little. And he goes on to say, in the Popperian picture of scientific progress, it is not observations, but problems, controversies, theories, and criticism that are primary, end quote. Perfect, wonderful, that's exactly right. The crypto-inductivist has got it. He goes on to say, experiments are designed and performed only to resolve controversies. Therefore, only experimental results that actually do refute a theory, and not just any theory, it must have been a genuine contender in a rational controversy, constitute corroboration. Pausing there, my reflection. Yeah, I don't need the corroboration bit, right? So you've got, therefore, only experimental results that actually do refute a theory, and not just any theory. It must have been a genuine contender in a rational controversy. We don't need to say that it constitutes corroboration, although, as I said in my last episode, unless, of course, you think this corroboration thing is a synonym for refutation, which would be a bit weird. We don't need both. We can just say we've got these competing theories, one of which gets refuted, leaving us with only one. Now, you could call that process, well, we've corroborated this one existing theory. It just gets a little bit misleading, that's all I would say. It suggests that we've confirmed as more likely true, something or other. It contains more truth. It's closer to describing reality than the one that has been refuted. Of course, it's necessarily the case. Okay, skipping a bit, and the crypto-inductivist goes on to say, quote, suppose that a theory has passed through this whole process. Once upon a time it had rivals. Then experiments were performed and all the rivals were refuted, but it itself was not refuted. Thus it was corroborated. What is it about being corroborated that justifies our relying on it in the future? And David says, since all its rivals have been refuted, they are no longer rationally tenable. The corroborated theory is the only rationally tenable theory remaining. Pausing there, my reflection. Again, I think this might be the last time I'll just go back and say this sort of thing. But again, it would seem to me that we can just do away with that way of saying things. Instead of saying the corroborated theory is the only rationally tenable theory remaining, you just say the unrefuted theory is the only rationally tenable theory remaining. And again, if corroborated means unrefuted, very well. The crypto-inductivist goes on to say, quote, but that only shifts the focus from the future import of past corroboration to the future import of past refutation. The same problem remains. Why exactly is an experimentally refuted theory not rationally tenable? Is it that having even one false consequence implies that it cannot be true? And David says, yes. And the crypto-inductivist goes on to say, but surely as regards the future applicability of the theory, that is not a logically relevant criticism. Admittedly, a refuted theory cannot be true universally. In particular, it cannot have been true in the past when it was tested. But it could still have many true consequences, and in particular, it could be universally true in the future. And David responds, this true in the past and true in the future terminology is misleading. Each specific prediction of a theory is either true or false. That cannot change. What you really mean is that though the refuted theory is strictly false, because it makes some false predictions, all its predictions about the future might nevertheless be true. In other words, a different theory, which makes the same predictions about the future, but different predictions about the past might be true. And the crypto-inductivist says, if you like. So instead of asking why a refuted theory is not rationally tenable, I should, strictly speaking, have asked, why does the refutation of a theory also render untenable every variant of the theory that agrees with it about the future, even a variant that has not been refuted? David says, it is not that refutation renders such theories untenable, it is just that sometimes they already are untenable by virtue of being bad explanations. And that is when science can make progress. For a theory to win an argument, all its rivals must be untenable, and that includes all the variants of the rivals which anyone has thought of. But remember, it is only the rivals which anyone has thought of that need be untenable. For example, in the case of gravity, no one has ever proposed a tenable theory that agrees with the prevailing one in all its tested predictions, but differs in its predictions about future experiments. I am sure that such theories are possible. For instance, the successor to the prevailing theory will presumably be one of them, but if no one has yet thought of such a theory, how can anyone act upon it? And the crypto-inductivist says, what do you mean no one has yet thought of such a theory? I could easily think of one right now. And David says, I very much doubt that you can. And the crypto-inductivist says, of course I can. Here it is. Whenever you, David, jump from high places in ways that would, according to the prevailing theory, kill you, you float instead. Apart from that, the prevailing theory holds universally, end quote. Okay. I am not going to read the next few pages of... Well, I'll read a little bit. But basically, the whole idea is here that the crypto-inductivist claims to have invented a theory on the spot. Namely that the prevailing view of gravity holds always, all the time, universally, except that in this particular case, just ad hoc, he floats. Now, I say, and as David will go on to say, of course, this is not a theory. This is not an explanation. This is not genuinely solving any problem at all. It's just an ad hoc modification with an assumption that comes out of nowhere. That the whole purpose of science is a problem-solving exercise. That's what we're doing. This solves no problems. In fact, it introduces problems. It breaks the existing theory, and this is what David says. So let me just read the relevant part, because just as with David, even that's David's character, the crypto-inductivist is an irritating person. These people almost exist in real life. Anyway, so the crypto-inductivist says, what's wrong with this theory? Why can't I just make this ad hoc modification? You know, what fault, what mistake have I made? David explains, quote, just about every fault in the Popperian book, your theory is constructed from the prevailing one by appending an unexplained qualification about me floating. That qualification is, in effect, a new theory, but you have given no argument either against the prevailing theory of my gravitational properties or in favour of the new one. You have subjected your new theory to no criticism, other than what I am giving it now, and no experimental testing. It does not solve, or even purport to solve, any current problem. Nor have you suggested a new, interesting problem that it could solve. Worst of all, your qualification explains nothing but spoils the explanation of gravity that is the basis of the prevailing theory. It is this explanation that justifies our relying on the prevailing theory and not on yours. Thus, by all rational criteria, your proposed qualification can be summarily rejected." End quote. And I think that, this is the point at which the judge comes along and hammers the gavel. It's case closed kind of thing. But still the crypto-inductivist goes on and on and on, trying to say the ways in which, you're still not justified. He gets to a point, the crypto-inductivist, where he says, well, I could use this new verb, ex floats, to describe situations in which you might fall to the ground, but in other cases you just happen to float unsupported, so I can invent new language and stuff like that. So he says, the crypto-inductivist says, "But when the theory is translated into my language, no qualification is manifest, and on the contrary, a manifest qualification appears in the very statement of the prevailing theory." And David says, "So it does. But not all languages are equal. Languages are theories. In their vocabulary and grammar, they embody substantial assertions about the world. Whenever we state a theory, only a small part of its content is explicit. The rest is carried by the language. Like all theories, languages are invented and selected for their ability to solve certain problems. In this case, the problems are those of expressing other theories in forms in which it is convenient to apply them and to compare and criticize them. One of the most important ways in which languages solve these problems is to embody implicitly theories that are uncontroversial and taken for granted, while allowing things that need to be stated or argued about to be expressed succinctly and cleanly." And the crypto-inductivist accepts that. And David goes on to say, "Thus it is no accident when a language chooses to cover the conceptual ground with one set of concepts rather than another. It reflects the current state of the speaker's problem situation. That is why the form of your theory in English is a good indication of its status vis-à-vis the current problem situation, whether it solves problems or exacerbates them. But it is not the form of your theory that I am complaining about. It is the substance. My complaint is that your theory solves nothing and only exacerbates the problem situation. This defect is manifest when the theory is expressed in English, and implicit when it is expressed in your language, but it is no less severe for that. I could state my complaint equally well in English or in scientific jargon or in your proposed language or in any language capable of expressing the discussion we have been having. It is a Popperian maxim that one should always be willing to carry on the discussion in the opponent's terminology." End quote. Now, I would just say there's a lot there that is extremely useful for day-to-day life. If you're engaged in a discussion with someone, especially in philosophical discussions where people tend to like to just philosophize in completely abstract terms, divorced from physical reality or any other kind of reality for that matter, thought experiments, trolley problems and that kind of thing. What you want to say to them in these situations is a simple question. Ask a simple question. What problem are you solving? What problem are you solving? Okay, and let them go down the road. And if it's a completely abstract problem about, these people are tied to a railway and you have a lever, and it's like, well, hold on. That is an imaginary situation. Can we bring it back to something in the real world? And let's talk about something in the real world. And let's get to, let's say, moral principles or what's physically possible in the real world and what one would really do in the real world, because that's imaginary. That's never happened before. And insofar as things like that might have happened somewhere at some point, we call those things edge cases. It doesn't affect the general rule, the general approach to life that people have. And also in these situations, and what David has just hinted at there, is that language is there to solve a problem. And so, again, once more, you listen to certain philosophers on certain podcasts at times, people get interviewed, and they invent words, they invent terms of vocabulary, and they think that by inventing these words, they're solving some problem. But in fact, what they're doing, they're exacerbating the problem. They're generating issues that weren't there before. The prevailing existing view, the way of talking about these things, solves certain problems, might have certain open problems, but their invention of new words, it just introduces yet more problems without solving anything existing. They're often trying to say, I've discovered something because I've invented a term. Here I've got a piece of jargon. And that solves the problem. It doesn't solve the problem at all. You're describing the problem using new bits of language. And inventing, the proliferation of language, neologisms, is just something I always irritates me. Sometimes it's unavoidable. Of course, when a scientist, when a thinker really truly does come up with a solution, because they postulate the existence of entities that hitherto we didn't know about, of course you need a new word for that. You need the word electron once someone has figured out that there is this little particle that carries this little negative charge. Well, you need a word for that, okay? Fine. We accept that. But there are many cases where the proliferation of language seeks to obscure what's really going on rather than solving an actual problem. Always ask, what problem are you trying to solve? You're introducing this new term. What is the specific problem you're trying to solve? Let's talk about solutions rather than inventing words that are only kind of describing a problem that's out there. I'll hop off my hobby horse now. I'll pick it up where David is going on to just hammer his point home to the crypto-inductivist. And he says, quote, "Your theory asserts the existence of a physical anomaly, which is not present according to the prevailing theory. The anomaly is my alleged immunity from gravity. Certainly, you can invent a language which expresses this anomaly implicitly so that statements of your theory of gravity need not refer to it explicitly. But refer to it they do. A rose by any other name would smell as sweet. Suppose that you, indeed suppose that everyone, were a native speaker of your language and believed your theory of gravity to be true. Suppose that we all took it entirely for granted and thought it so natural that we used the same word for X-fall to describe what you or I would do if we jumped over the railing. None of that alters in the slightest degree the obvious difference there would be between my response to gravity and everything else's. If you fell over the railing, you might well envy me on the way down. You might well think, if only I could respond to gravity as David does, rather than in this entirely different way that I do, end quote. And perfectly right. Right. Remember what's going on. The guy is claiming, the crypto-inductivist is claiming that if David jumps over, he's going to float. But everywhere else, every other time anything else happens, the prevailing theory just operates as normal. This is one of those situations where, you can imagine a philosopher making this argument. It's just like, well, why are you even asking it? What problem are you solving? They're saying, well, I want to figure out exactly why we should be justified in relying upon the predictions of our existing explanations. Well, I'm telling you, there is only one explanation. And then they go down this long road where it even requires the invention of a new language in order to try and explain a problem that doesn't exist. It's just not a problem. It just isn't an issue that David is going to float and everything else is going to fall. That's not the situation we're in. If it was, then that would be a genuine problem, as David says there. Then everyone would be wondering, why is it that the laws of gravity appear to have selected David Deutsch out of everyone in the entire universe for special treatment? What's going on there? That would be a problem, and there would need to be an account of that. But that's not the situation we're in. It's all in the crypto-inductivist's head. Kind of like a trolley problem, right? It's all in your head. That you need to push the fat man off the bridge in order to save the others. It's in your head. That's not happening. Can we talk about something real? Then that's where the interesting philosophy comes in. Philosophy is most interesting, not when you're talking about, to my mind, the things like Descartes' demon and the simulation hypothesis and far distant future existential threats. It's the here and now. It's problems right now that need addressing right now, and which people are struggling to find answers to. And maybe some people just give up and they go, oh, look, that's too hard. I'm not going to worry about trying to deal with the issue right now of things like coercion that exist in society. Let me talk about the far distant future. I can deal with that. I can deal with the science fiction reality of the year 3000 when, the AIs are going to take over. That's more fun to talk about. This is philosophy, though. This is sometimes what passes for philosophy. And the crypto-inductivist is still just rattling on. I encourage you to read the entire chapter. I'm not going to, as I say, so I'm skipping a number of pages, and I'll just pick it up where David says, quote, "Theories postulating anomalies without explaining them are less likely than their rivals to make true predictions. More generally, it is a principle of rationality that theories are postulated only in order to solve problems. Therefore, any postulate which solves no problem is to be rejected. That is because a good explanation qualified by such a postulate becomes a bad explanation." End quote. Yes, and as I was just saying about, philosophers who like to consider problems of the distant future. What's going to happen in the year 2500 when the AGI are finally here? Are they going to take over all of humanity? It's like you're inventing a problem of the future. We're not there yet. That's not our problem right now. How we should start preparing for war with the AGI or with the aliens that we haven't detected yet. This kind of stuff is solving no problem. It's not really part of rational discussion. I mean, it's fun, but it's more in the realm, as I like to say, of science fiction. Now, science fiction can be useful. And, this is kind of a fun thing to do late on a Friday night after you've had a beer or a wine with a friend to discuss the possibilities of the encounter between alien life and humanity and what problems might be involved then. But it's not our problem situation right now. This is not the problem we have right now. There are problems right now. I'm not saying anyone should not necessarily think about those things, that those things can't be fun. What I'm saying is that that's not a part of serious philosophical discussion and rationality. As much as people get out there onto podcasts and start talking about these things, you're not solving any problems right now. There are problems right now. There are problems right now that a philosopher should direct their attention to. People love to listen to stories and hypotheses about what UFOs are, and people speculate about what these different things are. But insofar as it's a problem, it's not a serious problem. If the Star Destroyer populated by stormtroopers appears in the sky and is as big as an entire city, then we've got a problem. Let's talk about it then. Should we prepare for that? No. Why not? Why shouldn't we prepare for the distant future of things? Because there is an infinite number of things we can imagine that are terrible off into the distant future. But learned people all tend to agree that this particular problem about catastrophic AI apocalypses is the most important problem. I don't care. I don't care that there's so many of these people talking about that particular thing. It's not our situation now. I think that those people have perhaps too much time on their hands. They should be focusing their brain power on problems of today, right now, rather than being concerned about existential threats of tomorrow. But of course, people can do what they like. Okay, I want to pick up something that I mentioned, and I prefaced in the immediate previous episode of Topcast when I was talking about corroboration. And well, the issue is this. Let me just read a part here. And the crypto-inductivist is saying that he's beginning to agree with David. And he says, quote, "Now that I understand there really is an objective difference between theories which make unexplained predictions and theories which don't, I must admit that this does look promising as a solution to the problem of induction. You seem to have discovered a way of justifying your future reliance on the theory of gravity, given only the past problem situation." Skipping a little, and David says, "It was not I who discovered this." And the crypto-inductivist says, "Well, I don't think Popper did either. For one thing, Popper did not think that scientific theories could be justified at all. You make a careful distinction between theories being justified by observations, as inductivists think, and being justified by argument. But Popper made no such distinction, and in regard to the problem of induction, he actually said that although future predictions of a theory cannot be justified, we should act as though they were." And David says, "I don't think he said that exactly. If he did, he didn't really mean it." Pausing there, just my reflection. Yeah, I kind of get this impression as well from my reading of Popper, especially recently, and as I said in the last episode. Popper just wrote so many thousands of words, thousands of pages, thousands of words. And so it gets hard. It's like me, talking here on Topcast. You kind of, it's hard to keep track of what you did say in the past. I feel as though I've got a reasonably coherent worldview, and people ask me about aspects of it, and I can respond near immediately to what I think is the case. But I can certainly imagine misspeaking now and again, or not quite constructing the sentences precisely in the same way that I did in the past as I will in the future, because it's just hard to keep track of everything. We're human. Now, Popper was operating in a time where he's writing by hand or he's typing or whatever it happens to be the case and trying to keep track of everything he's written. And indeed, he says of himself that he changes his mind between the logic of scientific discovery through realism and the aim of science and various other things. And I do get the impression that he said, well, he didn't really mean to say things like, you can confirm your theory. Okay, or there are confirming instances of a theory. That's one thing he actually says. He actually rejects a version of himself in realism and the aim of science. And so let me just repeat what David says there, basically on the same topic. The crypto-inductivist has just said, in regard to the problem of induction, he, Popper, said that although future predictions of a theory cannot be justified, we should act as though they were. David says, I don't think he said that exactly. If he did, he didn't really mean it. The crypto-inductivist says, what? And David says, or if he did mean it, he was mistaken. Why are you so upset? It is perfectly possible for a person to discover a new theory, in this case, Popperian epistemology, but nevertheless to continue to hold beliefs that contradict it. The more profound the theory is, the more likely this is to happen. Crypto-inductivist says, are you claiming to understand Popper's theory better than he did himself? And David says, I neither know nor care. The reverence that philosophers show for the historical sources of ideas is very perverse, In science, we do not consider the discoverer of a theory to have any special insight into it. On the contrary, we hardly ever consult original sources. They invariably become obsolete, as the problem situations that prompted them are transformed by the discoveries themselves. For example, most relativity theorists today understand Einstein's theory better than he did. The founders of quantum theory made a complete mess of understanding their own theory. Such shaky beginnings are to be expected, and when we stand upon the shoulders of giants, it may not be all that hard to see further than they did. But in any case, surely it is more interesting to argue about what the truth is than about what some particular thinker, however great, did or did not think, end quote. Isn't that marvellous? That's perfect. I agree entirely with that. No one learning science learns from the original research papers. No one tempted to learn special relativity should go back to, Einstein's original paper, presumably in German, by the way. No one consults the original struggling attempts to understand the photoelectric effect and the beginnings of quantum theory. No! You don't even go to Everett's papers. You go to the beginning of infinity. You go to modern accounts of how to understand this stuff. Modern textbooks in many, many cases explain things so much better. It's, sometimes the scientists, people can be brilliant scientists and make great insights and yet be terrible communicators of their ideas. It takes other reasonably good scientists who are better communicators to distill out what is actually being said. And then perhaps textbook writers who are a different kind of person again to distill out what the good communicators of science are actually saying about the truth of science. And then you end up with textbooks, which can be quite good accounts of our best existing theories. And then eventually, after all of that, you might get popular accounts of what's going on, which can be even better. Sometimes worse, sometimes misleading. Sometimes they introduce yet new misconceptions. But, this is, if you want to understand something, is why you should read widely a whole bunch of different things. Certainly, this has been my experience of, reading some of the research papers, reading some of the textbooks, and then reading some of the popular science books and being able to see what they all have in common, where they agree on what the experiments are saying, what actually makes rational sense, what actually accounts for what's going on, what has the best explanations, which is one of the reasons I am so fixated on David Deutsch's worldview, which talks so much about explanations, puts explanations at the center of rational understanding, that if you don't understand something, that's a problem. But it might not be you that's the problem. It could be the person ostensibly doing the explaining, the textbook, the lecturer, whatever. They could just be not understanding the phenomena themselves and giving you a non-explanation, being evasive. And so you have to somehow or other find the person that knows the stuff and is able to explain it well. What you don't want in physics, for example, is an instrumentalist. And yet they are a dime a dozen. They're out there and they just say, well, let's just crank through the formulae. Let's just figure out how to do the calculations. There you go, you're a physicist. Well, you might be competent at the mathematics, at turning the handle, which at one end you put in your initial conditions and out the other end you get your final conditions, you get your solution. And you don't really understand what's going on. You don't understand what the turning of the handle is really all about. You may not appreciate what reality really consists of. In fact, you may have even been told you can't understand what reality consists of, not even approximately. There is no understanding reality. The best you can do is to predict the outcome of experiments. And this is all wrong. Okay, this is all wrong. But people who first discover a theory, they're struggling to understand stuff. And so they're throwing stuff at the blackboard and the whiteboard and, writing papers and trying to get other people to see if they can understand it as well and if they agree with the results and what their conclusions might be. And people are hypothesizing things. And it takes some time for the dust to settle, so to speak. Okay, so I'm going to pick it up where the crypto-inductivist almost gets the idea and then falls back into bad ways of thinking. Because they say, quote, look, you, David, have justified a theory about the future, the prevailing theory of gravity, as being more reliable than another theory, the one I proposed. Even though they are both consistent with all currently known observations, since the prevailing theory applies both to the future and to the past, you have justified the proposition that, as regards gravity, the future resembles the past. And the same would hold whenever you justify a theory as reliable on the grounds that it is corroborated. Now, in order to go from corroborated to reliable, you examine the theory's explanatory power. So what you have shown is that what we might call the principle of seeking better explanations, together with some observations, yes, and arguments, imply that the future will, in many respects, resemble the past. And that is a principle of induction. If your explanation principle implies a principle of induction, then logically it is a principle of induction. So inductivism is true after all, and a principle of induction does indeed have to be postulated, explicitly or implicitly, before we can predict the future. And David says, oh dear, this inductivism really is a virulent disease. Having gone into remission for only a few seconds, it now returns more violently than before. And the crypto-inductivist says, does Popperian rationalism justify ad hominem arguments as well? I ask for information only. David says, I apologise. Let me go straight to the substance of what you said. Yes, I have justified an assertion about the future. You say this implies that the future resembles the past. Well, vacuously, yes, inasmuch as any theory about the future would assert that it resembled the past in some sense. But this inference that the future resembles the past is not the sought-after principle of induction, for we could neither derive nor justify any theory or prediction about the future from it. For example, we could not use it to distinguish your theory of gravity from the prevailing one, for they both say in their own way that the future resembles the past. Yes, end quote. And by the way, here, an explanation that sort of suggests that the past resembles the future, as David says there, well, that's a vacuous claim. It's like a universal theory of gravity or anything else is universal, which means the future resembles the past resembles the future, the near resembles the far, in this respect of obeying that law. That's all. It's like, any claim in relativity about the constancy of the speed of light. The speed of light is constant. The speed of light was constant at the beginning of the universe. The speed of light was constant 10 billion years ago. The speed of light was constant 1 billion years ago. The speed of light is constant today, and the speed of light will be constant tomorrow. That's not a principle of induction. That's just because you're saying that these things are the same is not going to justify some theory. It's just a logical conclusion or a logical thing that you can say that falls out of what we understand about relativity, our best explanation of space, time and light in this particular case. As David goes on to say, and I'm skipping a bit, but he says, quote, nothing in the concepts of rational argument or explanation relates the future to the past in any special way. Nothing is postulated about anything resembling anything. Nothing of that sort would help if it were postulated, in the vacuous sense in which the very concept of explanation implies that the future resembles the past, it nevertheless implies nothing specific about the future, so it is not a principle of induction. There is no principle of induction. There is no process of induction. No one ever uses them or anything like them, and there is no longer a problem of induction. Is that clear now? And the crypto-inductivist says, yes. Please excuse me for a few moments while I adjust my entire worldview. Now, David goes on to explain. Well, let me read part of his explanation. He says, quote, in response to the crypto-inductivist, as we have agreed, your theory consists objectively of a theory of gravity, the prevailing theory, qualified by an unexplained prediction about me. It says that I would float unsupported. Unsupported means without any upward force acting on me. So the suggestion is that I would be immune to the force of gravity, which would otherwise pull me down. But according to the general theory of relativity, gravity is not a force, but a manifestation of the curvature of space-time. This curvature explains why unsupported objects like myself and the Earth move closer together with time. Therefore, in the light of modern physics, your theory is presumably saying there is an upward force on me, as required to hold me at a constant distance from the Earth. But where does that force come from and how does it behave? End quote. David does go on, but we can just see here that this unsupported assertion about reality that the crypto-inductivist has introduced creates more problems. It doesn't solve anything, it creates more problems. And our project is, in science and everywhere else, to solve problems so that we can move on to better problems, not introduce new problems that weren't there before so that we've actually ruined the existing solution. No. That's not what we're supposed to be doing. And this, by the way, is why, there's this trope idea among physicists that retired engineers tend to go into proving Einstein wrong. Using simple algebra, they show you that, well, the speed of light can't be constant, or you can travel faster than the speed of light, or any number of things. There's no such thing as the relativity of simultaneity or the relativity of time, and all this kind of stuff. So the problem with these approaches for any physicist who receives such a letter from a retired engineer, it's a bit unfair to these poor retired engineers. I'm sure they're not all retired engineers, but physicists know what I'm talking about. They receive emails and letters of this kind, such and such has got the new theory of relativity. They're never solving any problem. They're never solving an existing problem in science. What they're doing is they're objecting on common sense grounds to some conclusion of relativity, let's say. They don't like the idea that there should be a relativity of simultaneity, that things appear to happen at the same time or not, depending upon whether you're moving or not with those things that are happening at the same time. Or they don't like the idea that lengths can contract. If you move faster, then things get shorter. They don't like the idea that the speed of light is constant. Any number of things like this. And so because they don't like it, they invent a new theory that, far from solving any problems, breaks the existing theory, the theory of relativity, and introduces new problems. So then it means that, well, we can't explain what's going on. If we were to use the retired engineer's explanation of reality, we can't explain what's going on in places like the Large Hadron Collider. We can't explain what's going on with the GPS system, which we can explain perfectly well using general relativity, and in many cases special relativity as well. And so this is the issue here. You aren't solving a real problem. What you're doing in those situations is you don't understand something and you're trying to understand something. And rather than trying harder to understand something by asking questions of people who might know more, who in a patient way will explain it to you, you just say, I'm throwing it all out and I'm telling you what the truth is. Being a little dogmatic, let's say. After a little more back and forth, we again come back to David saying, quote, your additional postulate is not just superfluous, it is positively bad. In general, perverse but unrefuted theories which one can propose off the cuff fall roughly into two categories. There are theories that postulate unobservable entities, such as particles that do not interact with other matter. They can be rejected for solving nothing, Occam's razor if you like. And there are theories like yours that predict unexplained, observable anomalies. They could be rejected for solving nothing and spoiling existing solutions, It is not, I hasten to add, that they conflict with existing observations. It is that they remove the explanatory power from existing theories by asserting that the predictions of those theories have exceptions, but not explaining how. End quote. The crypto-inductivist says, I see that now. Now will you give me help in adjusting my worldview? David says, well, have you read my book, The Fabric of Reality? But what the crypto-inductivist then goes on to ask of David, well, he says, quote, what I cannot understand is where in that raw material, past observations, the present problem situation and timeless principles of logic and rationality, none of which justifies inferences from the past into the future, the justification of future predictions has come from. There seems to be a logical gap. Are we making a hidden assumption somewhere? And David responds, no, there is no logical gap. What you call our raw material does indeed include assertions about the future. The best existing theories, which cannot be abandoned lightly because they are the solutions of problems, contain predictions about the future, and these predictions cannot be severed from the theory's other content as you tried to, because that would spoil the theory's explanatory power. Any new theory we propose must therefore either be consistent with these existing theories, which has implications for what the new theory can say about the future, or contradict some existing theories but address the problems thereby raised, giving alternative explanations, which again constrains what they can say about the future. And the crypto-inductivist says, so we have no principle of reasoning which says that the future will resemble the past, but we do have actual theories which say that. So do we have actual theories which imply a limited form of inductive principle? David says, no. Our theories simply assert something about the future. Vacuously, any theory about the future implies that the future will resemble the past in some ways, but we only find out in what respects the theory says that the future will resemble the past after we have the theory. You might as well say that since our theories hold features of reality to be the same throughout space, they imply a spatial principle of induction to the effect that the near resembles the distant. Let me point out that in any practical sense of the word resemble, our present theories say that the future will not resemble the past. The cosmological Big Crunch, for instance, the recollapse of the universe to a single point, is an event that some cosmologists predict, but which is just about as unlike the present epoch in every physical sense as it possibly could be. The very laws from which we predict its occurrence will not apply to it, end quote. And exactly the same argument applies with what we know of cosmology today. The far distant future, apparently, given what we know now, and this is very much open to change given future observations and future theories, of course, is that this dark energy is going to continue to accelerate the expansion of space such that everything gets ripped apart in this kind of big rip event where even atomic nuclei and fundamental particles get torn apart and everything turns into photons. And, at that point, if you listen to someone like Roger Penrose, you have at the very end of time, after this happens, something that looks very much like the beginning of time, namely a universe or a space that contains no matter and nothing but photons, which is precisely what the Big Bang was like. Anyway, that's off topic, but the point is that right now, the present doesn't resemble the past, the Big Bang, and it doesn't resemble the future, which is this far distant big rip future. Who knows? I'm skipping past a bit where they get into a discussion about what justifies as being true the principles of logic and how the justifications for logic isn't perfectly secure, and David agrees it's not perfectly secure. We can't expect it to be. What we want are good explanations, of course. We want explanations about why and how rationality works. They come across the Turing principle, and the crypto-inductivist asks how we know it's true, and David says, we don't know, of course. In fact, let me just read what he says on that. When he's confronted with, is the Turing principle true? David says, we don't know, of course, if it's true or not, but you are afraid, aren't you, that if we can't justify the Turing principle, then we shall once again have lost our justification for relying on scientific predictions. And the crypto-inductivist says, yes. David says, but we have now moved on to a completely different question. We are now discussing an apparent fact about physical reality, namely that it can make reliable predictions about itself. End quote. That's in the form of us, right? We are the thing that makes reliable predictions about the future. So we are part of physical reality that makes reliable predictions about physical reality. Continuing, David says, we are trying to explain that fact, to place it within the same framework as other facts we know. I suggested that there may be a certain law of physics involved, but if I were wrong about that, indeed, even if we were entirely unable to explain this remarkable property of reality, that would not detract one jot from the justification of any scientific theory, for it would not make the explanation in such a theory one jot worse. And the crypto-inductivist says, now my arguments are exhausted. Intellectually, I am convinced, yet I must confess that I still feel what I can only describe as an emotional doubt. And David says a few things, but then gets to the meat of the matter and says, quote, the misconception is about the very nature of argument and explanation. You seem to be assuming that arguments and explanations, such as those that justify acting on a particular theory, have the form of mathematical proofs, proceeding from assumptions to conclusions. You look for the raw material, axioms, from which our conclusions, theorems, are derived. Now, there is indeed a logical structure of this type associated with every successful argument or explanation, but the process of argument does not begin with the axioms and end with the conclusion. Rather, it starts in the middle, with a version that is riddled with inconsistencies, gaps, ambiguities, and irrelevancies. All these faults are criticised. Attempts are made to replace faulty theories. The theories that are criticised and replaced usually include some of the axioms. That is why it is a mistake to assume that an argument begins with, or is justified by, the theories that eventually serve as its axioms. The argument ends tentatively when it seems to have shown that the associated explanation is satisfactory. The axioms adopted are not ultimate, unchallengeable beliefs. They are tentative, explanatory theories. End quote. Yeah, and all I would say there, just in other words, is the argument ends tentatively when it seems to have solved the problem. Solved the problem to the satisfaction of whoever had the problem. And that could be the community of scientists or an individual scientist working on a particular issue. So that's the way things go. And it doesn't just have to be science, of course. This applies universally to all problem situations and all kinds of knowledge creation. The crypto-inductivist finally agrees, and he says, quote, I see. Argument is not the same species of thing as deduction, or the non-existent induction. It is not based on anything or justified by anything, and it doesn't have to be, because its purpose is to solve problems, to show that a given problem is solved by a given explanation. And David says, welcome to the club. and the crypto-inductivist has now been retitled Ex-inductivist. And he says, all these years I have felt so secure in my great problem. I felt so superior both to the ancient inductivists and to the upstart Popper, and all the time without even knowing it, I was a crypto-inductivist myself. Inductivism is indeed a disease. It makes one blind. And there are a few more remarks at the end there, but we may as well also throw into the bin here the Bayesians, the modern incantation of inductivists. Okay, they have this induction-shaped hole in their epistemology. Almost everyone who's not a Popperian does. So-called objectivists do as well. They seek a principle of induction, this secure foundation from which they can derive explanations in the same way that mathematical proofs are derived. It's as if, as David says elsewhere in The Fabric of Reality, there's this hierarchy of knowledge creation or of argumentation where mathematics is the king of all knowledge and everything seeks to aspire to be like mathematics, to start with a secure foundation, with axioms that are self-evident, that are absolutely true, that cannot be denied. And from that, you just use your rules of inference, which presumably also are completely inerrant, that can only produce truth from truth. And you get thereby true conclusions. This way of thinking about reality and the way of constructing knowledge is completely misconceived. Among other things, who says and who can prove, and why should we believe that the axioms are themselves absolutely true? We don't know. If the process is this method of deduction in order to generate true conclusions, if that's the process, then wherefore the axioms? How did we get these true axioms in the first place? As David says there, you start in the middle, we start with the problem, and it's a messy kind of process of creating an explanation. No one really knows how it happens yet. We don't have an explanation for creativity yet. We just know that we come up with these creative explanations of reality. They're hard to vary because Each part of the explanation corresponds to some part of reality, postulating into existence some physical thing when it comes to science, something that is accounted for by the explanation. So that's where we'll leave Chapter 7 of the Fabric of Reality. Next time, once I do come back to the Fabric of Reality, we'll be on to the Significance of Life, which is Chapter 8, all about evolution by natural selection. But until then, bye-bye.